Hello my dear students, welcome to video number 146 of my channel MALACHEMPHILIC, and this 146 video is the episode number 85 of the course Chemical Thermodynamics. Here the topic is zeroth law of thermodynamics. Actually, this should be the first topic of the course, but somehow by mistake it was skipped from my brain. I didn't do it earlier. So at the end I am discussing this zeroth law of thermodynamics. So let's see. Before coming to the zeroth law of thermodynamics, we should understand the thermal equilibrium. If I want to explain the very specific definition of thermal equilibrium, then it will be like that. These two objects, there are two objects or the two systems. So this is one system, this is one system. Their temperature is different and they are in contact with each other. Then what will happen? That heat will flow from the hot to cold, hot body to the cold body, or hot system to the cold system, and it will flow until and unless their temperature will become same. That means that time there will be no net flow of the heat between them, and then these two systems we are said to be in thermal equilibrium. So main condition of thermal equilibrium means two systems which are in contact with each other, there will be no heat flow between them. That means their temperature is same. That is the condition for thermal equilibrium. This is very specific definition. So the same way, a point where there is no net flow of thermal energy between the two connected physical systems, then they are said to be in equilibrium. Now, let's try to understand this thermal equilibrium more widely, okay, in the wider sense. See, this is a system. It may be gaseous system, it may be fluid, solid, whatever it is. Okay, system A is a gaseous system. Here its pressure is P, volume V, temperature T, and it is kept in a closed and insulated vessel. That means it cannot transfer any energy or matter with the surroundings and vice versa. Okay. Then, so what we can write for this system? 1 minute. So what we can write for this system? No transfer of heat energy. This is one point. And obviously as it is closed, so no transfer of matter. Then what will happen? No change in the state variables that is temperature, pressure, volume, and also this mass, number of moles, anything. No change in the state variables or no change in the observable property with time. This is the main thing, with time. So, no change in the state, no change of state, because state variables are same, no change of state. So, system remains in the same state. System remains in same state. So then system is in equilibrium. Okay, and as the temperature is not changing, temperature also remains same. This is one of the observable property. Then it is in thermal equilibrium. So now the system is in equilibrium, mechanical equilibrium, and also thermal equilibrium. So equilibrium or thermal equilibrium means this observable property, temperature is one of the observable property, will not change with time. As temperature is not changing with time, other parameters are also not changing. So system remains in the same state. Okay, then the system is in the thermal equilibrium. Now coming to this diagram. Here there are two systems A and B. Here shears or fluid, anything. And here the pressure of A, PA, volume VA, temperature TA. Here it is PB, VB and TB. And they are kept in the insulated container. And moreover, this boundary between them also insulated. And here you see this temperature of A is not same as temperature of B. That means here TA is not is equal to TB. But still, as the boundary is insulated, so there is no net flow of the heat. So, because what we can write, T is equal to not TB. I am telling about this system. T is equal to not TB, but no heat flow or heat transfer, no heat transfer between the system, between the systems. When there is no heat transfer, this temperature of A remains constant TA, B remains constant TB, and other parameters or other state variables, pressure volume also remains constant for A and pressure volume also remains constant for B. That means the system A is in a particular state, no change in the state, because there is no change in the state variable. System B also in the particular states. Okay, there is no change in the state variables and no change in the observable properties with time. So temperature of system A also remains constant for a long time. Temperature of system B also remains constant. Then we can say here, as there is no heat transfer, so what we can say, that A and B are in thermal equilibrium. Okay, though thermal equilibrium, though temperature of A and B are different. Okay, but they are in thermal equilibrium because there is no heat transfer, and for each system temperature remains same, no change with time. Now coming to this system. Here what we have done, same system A and B, they are kept in insulated container, but here the boundary is made conducting. Okay, so here the condition is, number one condition is, I'll write conditions. First condition is boundary is made conducting. Okay, boundary is made conducting. This is number one. And their temperature, pressure, volume, everything is different. One more condition, TA, temperature of A is greater than temperature of B. When this is the condition, temperature of A is greater than temperature of B, and the boundary is conducting, that means they are in contact, that means transfer is possible. here the temperature is more means these molecules have more kinetic energy, because you know average kinetic energy directly proportional to temperature. It has more kinetic energy, it has less kinetic energy. So from this molecule will transfer heat because they are vibrating, moving more vigorously. So these molecules will transfer heat to this molecule, heat energy. So heat transfer will take place. That means heat energy transfer from A to B system. Okay, so now they are not in equilibrium, but after some time what will happen? After some time, temperature of A and B becomes same. Say this is T dashed. Okay, temperature of system A also T dashed, temperature of system B also T or T dashed. Okay, you can take it as T also. Temperature of system A and B both will become T. Okay, then what will happen? Then no transfer of heat. Okay, then we can say that now A and B are in equilibrium means mechanical equilibrium, thermal equilibrium, everything, and we can say they are in thermal equilibrium. They are in thermal equilibrium. Is that? So when temperature is changing, there are other parameters. Pressure volume will also change for A, and pressure volume also change for B, because with temperature that parameters also will change. But when the parameters are changed and temperature become constant now, both A and B, same temperature, then after reaching to that state, there will be no change in the observable property. That means no change in the temperature, pressure, volume, etc. And no change in the temperature, no heat flow. So now they are in equilibrium. Okay, and they are also in thermal equilibrium because there is no heat transfer. Temperature of both system A and B are same and it remains constant, and both system A and B remains in their particular state for long time. Okay. Now coming to the zeroth law of thermodynamics. See, here this is one system A, temperature is TA. This is another system B, temperature is TB. They are kept in a insulated closed container. Even the boundary between them also insulated. This is one condition. Another one, this another system C is kept here, okay, which is in contact with both A and B, and boundary between A and C or B and C is conducting. This is the condition. So boundary between these two systems and these two systems are conducting, but boundary between A and B are insulated. Now under this condition, what will happen if I consider, suppose considering, say if I consider this temperature of A, that is TA, is greater than Tc, then heat will flow from A to C. Heat will flow from A to C till this temperature of A and C become same. So heat flow, heat energy flow So heat is actually the mode of energy transfer. Okay. So heat energy flow, that means this mode of energy transfer here, it is heat. Heat energy flow from A to C till the temperature of A and C are same. Okay. Now, what will happen? Same thing happened with B and C, because here also it is conducting. So if I consider, suppose this Tc is greater than Tb, then what will happen? Heat flow from C to B, okay, till the temperature remains constant. So what will happen? So after some time, equilibrium is established between A and C, sorry. So after some time, one minute. So after some time, equilibrium established between A and C and also B and C. Okay. Equilibrium established means there now no heat transfer from A to C. The temperature of A and C becomes same. Similarly, no heat transfer from C to B. That is temperature of C and B will same. And their observable property of these systems will not change with time, right? So now they are in equilibrium, these two are also in equilibrium. Now if you just, after this condition, if you just remove this container, this boundary, insulation of this boundary, then what will happen? You will find that there is no heat transfer between A and B. Initially temperature was different, but now there will be no heat transfer between A and B. And you will find that this temperature of A and B will remain same. That means temperature of A is equal to, or we can say temperature of TA is equal to Tc, and this also will become is equal to Tb. Their temperature is same because heat flows till the temperature of A and C become same. Similarly, heat flows till the temperature of B and C becomes same. Okay, so both A and B temperature now is equal to temperature of C. So this is like that. That means, therefore, what is the conclusion? We can write TA is equal to TB. That means A and B are also in thermal equilibrium. A and B are also in thermal, they are in equilibrium and temperature is same, so thermal equilibrium. Temperature is same means no heat transfer, so temperature is made same. Okay. So what is the zeroth law of thermodynamics now? So zeroth law of thermodynamics is all about this thermal equilibrium. It says that if two systems are each in thermal equilibrium with the third system separately individually. So here we have seen that first A and C becomes, they are in thermal equilibrium individually. Similarly, B and C also in thermal equilibrium individually. Then what will happen? Then they are in, that means those two systems A and B are in thermal equilibrium with each other. So if A and C are in thermal equilibrium, B and C are in thermal equilibrium, then AB also in thermal equilibrium. So this is all about zeroth law of thermodynamics. Hope you have understood. Thank you.